Hello, everyone. Hi, welcome to this webinar, to this first Teachmeet on this Math 2.0 course. My name is Nairkaira, and I'm one of the moderators of the course, along with my colleagues Ben, Katerina, Irina, and Anastasia, who I believe they are also in the Teachmeet. As you may already know, Teachmeet is an informal way of sharing ideas among teachers, and today we have here 6 very good speakers that have done a great job to be here today with us and share with you, with the rest of the colleagues, best practices, examples, ideas, and interesting resources for your classes. So the way this webinar is going to work is that every speaker will get up to 5 minutes to speak. After 5 minutes, I have a bell here prepared, so I will ring the bell after the 5 minutes. We'll get no more than 5 minutes. This is the bell. Okay, I hope you can all hear it. Otherwise, I'll just let you know that your time is over, and that's it, and we need to move to the next speaker. The webinar is being recorded, so if you have any doubt or you need to leave earlier, don't worry, because it will be recorded, and we will share the webinar in the relevant section of the course, which I believe is 5.6, if I'm not mistaken. And without further ado, I think we will start. If you want to ask any questions, please write them on the chat. And at the end of the 6 presentations, we have 6 speakers. So at the end of the 6 presentations, we will ask the questions to them. So make sure that if you write the question, you address this question to all participants. Otherwise, the rest of the people, they are not be able to see them. Okay, so let's move now to the first speaker, which is Ulla Lambeck. Welcome, Ulla. I will give you the presenter's rights now. Okay, let me set up the chrono, the online chrono that I have here to set up the time. Okay, switch on your camera. Okay, let's see if we see you.
I hope it's working.
Yes.
Can hear?
I hear you, but I don't see you at the moment.
On the camera, it's here.
Okay. Can most of the people see? Okay. Please mute your phone. So, okay, we can hear now. It's fine. Don't worry.
I'm here.
Okay, so my chrono is ready. Are you ready to start?
Yes.
Okay, so good luck, and I hope you all enjoyed this Teachmeet. Okay? The floor is yours, Ulla. Bye.
Her name is Ulla Lambeck. I teach mathematics. My students are 13 to 15. Oh, some are 12. I am involved in an Erasmus Plus project, and this gave me the idea to what I'm going to tell you about today. I have the headline Trade and Equation, and it's because we try to find movies, and these inspire us in teaching math. This is inspired by a Greek movie. It's about how people in ancient times exchanged and tables and things like that. And it was a problem because they needed to store the views, and because that they found things which could be valuable, like feathers and stuff like that. And then later on, coins and banknotes came. To relate mathematics to life, try to use our hands and model the things. Ideas solve the problem in teams. We want to be innovative and new equations for each other. I will get back to that. We use GeoGebra and paper. And also this task I'm talking about can be used indoor as well as outdoor, part of the method. And in Denmark it's important they are physical active or in math classes. What is we make students work in teams, and each team has a color. I give them a template. The template is like this, and the students must come up with as many solutions solve the problem as possible. Then they turn over the template, and on the back side there's an empty template, and then I give them items, and now they build new equations for each other. Then the students rotate among the tables. The red with the red color stay behind, and all the other students move to the next table. Then they solve the equation. The red knows the solution and make a new one, and then the blue one stay behind. And in that way, they all are responsible. They make it more difficult. I have another template, and this one is for 2 equations with 2 unknown. And it's the same method. It's a good idea that they have items, because then they can build this as the hands to solve the problem. Then they make new equations, 2 equations with 2 unknown for each other, and rotate among the tables. The same method as I just told you about. And then when we have done that, we use GeoGebra. In the input line at the bottom here, they write the equations, and then GeoGebra solves the problem for them, because here you can see the line crosses. Solution is 3.1, and that means an apple is worth 3 smileys, as I wrote here, and a pear is worth 1 smiley. Then we pass on and we solve the problem with pen and paper, like we did in the old days. And task is going to be part of what we do at the mobility meet in Athens, and it'll be interesting if we work in the same way in our different countries. And what will follow is that we will talk about money and security and the currencies. I know that most of you have euro, but we do not have euro in Denmark. That's why it's important for us. And also, the members will visit our countries. Then we will talk about inflation and deflation. And finally, we talk about loan and interest rates. Here the Danish documentary. It's called The Luxury Trap, but that's a whole that's another story. I think I must be up very soon. Thank you for listening to me. I hope you like my idea, and if you have questions, you are free to ask.
Very well. Thank you very much, Ula. You have stick to the time, perfect. Let's see if we can do the same, okay? So the way everybody can have the chance to speak. So I'm gonna move now to the second speaker this evening, who is Adriana Latse from Albania. Adriana, I'm moving the ball right now, so you will be able to see the to move the lights. Can you show your camera, Adriana? Okay. We can see you at the moment. I think it's loading. We can hear you properly, so it's fine.
Yes, you can.
We can hear you, and I think we will be able to see you soon. Some background noises. We can see you now. It's fine.
You can hear? Can you hear?
Yes, we can hear. So I am hearing some background noises. So if you're not a speaker, please mute your microphone, because otherwise it will get a bit noisy. Okay?
Okay.
So Adrian, are you ready to start?
Yes.
Press the chrono. Okay. Back. There is
Thank you. Thank you. My name is Adriana Latte. I live in Tirana, Albania, and I graduated in Math and Physics faculty. I am a math teacher and work as a math teacher at a secondary school. Okay, okay. I like my work. I love my pupils, and I try to do the best at my work for my pupils. I'm also an e-twinning member. I like e-twinning. I like projects. I like learning events, especially because I like to meet my colleagues around Europe, to exchange our experience and to deliver it in my country. For today, I have choose to present for you some of my topics of my learning design created here in our course. So let's start with the first part of first module. Why is math popular? Actually, I don't like to accept that math that is the most important subject in the school to be unpopular. But in my opinion, math is unpopular because if the pupils don't learn one or some topics, and this is repeated by some times, okay, then math is making for them like a foreign language. And so I often say to my pupils, if you abandon math, it will abandon you. And let's continue with the second part of the first module, moving to math 2.0, in which we learned how to use the Babel. I use them for separating my math teaching in two parts. In the first part, what I have done and what I do actually at my work, which regards the traditional teaching, and the second part, what I have to do. So I will try to use technology at my teaching to ask from pupils to use math links at their homework and to offer them learning outside. And which is my capacity to personalize my lessons for my pupils. Okay, at my country, there are not the possibilities to use the technology in our lessons, so the only way that I have chosen to personalize my lesson is the practice in real life or analogy, or letting their imagination in different places out of the class, such as 3D center, etc. But for engaging students in the math classroom, I've practiced. Sometimes I say to them, you have to explain today the new topic to me. I don't know anything. I will ask, you will answer to me. It is more important for pupils to take the role of the teacher and we to take the role of the pupils. They take responsibility to learn as what they want to learn. I think that the math is the best taught using just a pen, and a piece of paper. About this, I think that three components like traditional teaching using technology and outside three components which if we can combine very good, we will make our subject more attractive and more useful for our pupils. But the most important, that's my opinion, the base of these three of our teaching will be traditional teaching, because of my opinion, in traditional teaching are included all the senses: writing, listening, thinking, speaking. Digital teaching is more real, more easy for teachers, and more funny for pupils. Learning in outdoors is more important because the students in this way matches the theory with the reality more easy. But at the traditional teaching, okay, there is working mixed groups or in groups regarding variables or pupils, and working in groups in this way there are more benefits, so they are more social, or they have to prepare to be leaders in their future, or they have to speak to each other. They take the responsibility to learn each other and to hear, to learn, to write. There are most important things that helps our students to be to improve their learning in math. Also, using the technology, it is more important tool in our teaching, but as everything, there are best parts and bad parts. So I see that one of the bad parts in using technology is that pupils speak so much to each other. They are more individual, and this has its benefits, but also aren't also bad things, as I said before. Thank you. Thank you for attending me.
Right on time.
Yeah.
Thank you.
Thank you.
Thank you, Adriana. Very
Thank you.
interesting. Let's move now to the next speaker. Is Moreno Contetti. I don't know if I am pronouncing this correctly. I should, but I'm not. He's coming from Italy, and he's gonna talk about maths and earthquakes. So I'm gonna give you the presenters rights now, Moreno.
I said now, yes.
It will be okay. Hello.
Hello.
Thank you for being here with us. And when you are ready to start, I will press the chrono as well. Okay. Thank you. Good luck.
I am Moreno Concetti. My learning design will be about earthquake and mathematics. So I am my degree is in applied mathematics. I teach mathematics and physics in a high secondary school in Milano Sabini, Italy. My students are from 15 to 19 years old. So this is a little summative about my teaching. The topic is a result about different branches. So this is one of the most important things that I consider for this teaching, from mathematics, physics, just so much more. So we can start with mathematics about the element start by the student during their career. So we can have a summative about all the elements studied by the students. So for instance, mathematical function, resolution of equation, and differential calculus. So I decided to about this topic because of the last event in Italy this year, so we can give some history about these events, but also the mathematics and the physics that can model this kind of events. Some basics can be a little bit mathematics, which is inside the two scales used for this kind of event, so Mercalli scale and Richter scale. We can go a little bit on. We can give some formulas from by step, from easier formulas to more complex formula. In particular, we can give, for instance, formula about intensity and magnitude, and also about strength, for instance. So this is the starting point for the students to obtain equations by their own, so they can try to give a different equation starting from this, and so they can discover if some different kind of equation have a sense or not. So next part is the cooperation among the students, because we can see if the ideas are right or not, and if they have a sense, so they can compare their ideas, and so they can debate this kind of ideas with the teacher. So the teachers can say if they have a sense or less, so they can improve their works in this way. So it makes a real computation. A very interesting method is the computation of the epicenter of an earthquake. So you can use the mathematics, the physics, and then use also a software to solve this kind of equation. This is an interesting applied activity. So it could be very important, the cooperation between the different teachers, different branches, for instance, mathematics technicians or science teachers, so they can improve this work. So the last part, but a very important part of the activity, is the part of the laboratory part and the visualization of the results. So they can produce data by simulation, for instance, by algebra. They can make external evaluation. So they can use, for instance, a smartphone camera. They make a statistical analysis of data by Excel, and they can video by using Movie Maker. So at the end, they can make some poster to summarize the activity by using AutoCAD, for instance. Here there is a link to a very funny activity that can be the starting point of our learning design. So end-up activity can be a final test divided into different parts. So there can be mathematics exercise, analysis of physical law, a PC laboratory test done by using, for instance, software learning during the activity, a quiz using the very famous Kahoot, so they can their smartphone students, and so they can make at the end a science laboratory exercise to prove by the whole data and make statistical elaboration. And for instance, I was thinking that an interesting way to make this kind of elaboration was to find the lesions of the building from the outside, and so the teachers can make a final revision and statistic result of this activity. Thank you.
Thank you very much, Moreno. Right on time as well. Perfect.
Thank you so much.
Okay. Thank you. We're gonna move now to the next speaker today, who is Antonio Anelli. Antonio, I hope you're getting ready. I'm gonna give the presenter's rights to you in a minute. It takes a bit more time because okay, I don't have the number at the beginning. Okay, Antonio, do you have the rights? Can you switch on your camera?
Yeah, I see you.
Okay, we can
Go
hear
ahead.
you. We can
Go
hear
ahead.
you. Are you ready to start?
Just
Okay.
okay.
No. Okay. So let's go. Good luck.
My Antonio Anelli. I'm 63 years old. I live in Italy and I've been teaching since 1984. At the moment, I'm teaching maths at Italian high school. My students are 16 years old and don't take it with the pressure in maths, but they are very interested in technology. So here is to involve them in something which is new and exciting, give a job opportunity, but also the knowledge of how to work safe according to aerial navigation rules. Forwards, my modest contribute. Thank you all for your attention.
So I need to stop you. Moreno, can you, because I give you the presenter's rights, can you give them back to me? Host rights. Otherwise, we don't see the slides from Antonio. I get the ball back. Okay, so now the presenter. Okay, and now I think we will be able to see the slides from Antonio. Hopefully, did the slides, Antonio? Okay, so you're good to go. Sorry, I will give you 30 more seconds at the end. Thanks.
This is Antonio Anelli. I'm 63 years old. I'm in Italy and I've been teaching since 1984. At the moment, I'm teaching maths at an Italian high school. My students are 16 years old and don't take a great delight or pleasure in maths, but they're interested in technology. So my idea is to involve them in something which is new and unusual, exciting, giving them a job opportunity, but also knowledge about how to work safe according to aerial navigation rules. This forwards my modest contribute. Thank you all for your attention. Unmanned aerial vehicle and projected geometry can become a job. Unmanned aerial vehicles, also called drones, are aerial vehicles with no pilot on board, which can perform professional services and many other operations. It's not a joke, and those who would like to practice such an activity must respect, for example, the Italian rules, whose purpose is to ensure the safety of people and goods. These were issued by HENAC, Italian Organization for Civil Aviation, on July 16, 2065, second edition. According to these rules, you must be 18 or older, be in possession of a medical certificate given by a medical examiner, assessing your mental and physical fitness, be in possession of a certificate of attendance and have passed the course at the Training and Testing Center, acquire an insurance for some amount of 1 million euro, purchase or construct a drone, declare the drone to the Civil Aviation Authority, and pay its recognition. Register your own drone on the site D-Fly. Classes and categories of drones are distinguished according to their weight, MAOW, maximum takeoff weight. It has, of course, they may change from country to country. MAOW lower than or equal to 300 grams, greater than 300 grams, lower or equal to kilograms, most common, greater to kilograms but lower than 25 kilograms, greater or equal to 25 kilograms but lower than 150 kilograms. Phase of aerial work by drones. Phase 1, flight planning by hand. Flight execution subject to verification of meteorological, geomagnetic conditions, electromagnetic interferences. Transfer or acquired images from the memory card of the wireless device. Transfer of the images from the device to the cloud using the 4G network. Processing on the cloud to get a preview. Processing of the image on a personal computer by specific software for the purposes. Validation of the results on screen, interpretation and acquisition of information of the intended process. A point A placed in the space object, two images of the same point, A the first, A the second, are needed. These are called homologous points. While 01 and 02 are the center of projection, as shown in the right slide below. If there is more than one point, an error shot is needed, making sure that the page longitudinal transversal overlaps, as in the right slide below. What is shown in the screenshot below. The model has been obtained using 84 images taken by my DJI Phantom 2V Plus, and the screenshot below shows the trajectory green, following the ruined position of the drone scanner and its orientation at the moment of snapshot. Here are some of the possible uses of drones: topography, architecture, thermography, entertainment, archaeology, forensics, survey, precision agriculture, last but not least, search and rescue, so important in land like Italy and its earthquake. And for a patient, and feel free to visit my website, www.aerialdronostro.com. When I recognize maps of science content in this presentation, think anywhere, because the step-by-step procedure to obtain the results, as illustrated in slide number 6, involves a logical process and a great idea and a great deal of competences. When we are working in this presentation, I have the possibility of environmental monitoring is the big challenge for future generations, and drones do it better, faster, and easier. With the multiplication of drones to help disadvantaged students in showing their competencies, certain conditions, Italian rules don't permit disadvantaged students able to use drones. Moreover, the coordination of movements required for this type of activities is a rules importance in this case. Thank you.
So thank you very much for this great presentation, also for respecting the time slot right on time. Thanks. So we're going to move now to our next speaker. In the meantime, if you have any questions or anything, please write them on the chat, and we will answer. We will ask them at the end of the presentation. I think Antonio, if the rights, can you give me the rights? Otherwise, I cannot change. Yeah.
Are very satisfied with this idea.
Are you hearing me? Can you give me the rights? Can you move the ball to me? Because otherwise I cannot give it to the next speaker. Okay.
Just a moment.
Thank you. Yeah.
Just a moment.
In the meantime, if you have any question or anything, post them on the chat. Okay, I don't have the ball. Antonio, can you try to give me the ball so I can speaker? Yeah, can you hear me?
Yes.
So take the ball, name your name, move it to post UN profile here at top. Can you see it?
No, I don't. Sorry.
If you go to my name to host UN and you click on the mouse, right click on the mouse, I want to change the role
The present.
to host. You need to choose host.
Host. Okay.
Okay, so hopefully it will work now.
All right.
Right. So now I have the rights again, and in the meantime we will move to the next speaker today, who is Pablo Fesenko from Ukraine. Pablo, are you ready to start?
Hello, Naya. Hello, everyone.
Hello, welcome. See you again. And so Pablo Fesenko is gonna talk about Raspberry Pi and how to build robots with it, if I'm not mistaken.
Yes, that's correct.
Okay, you ready to start then?
Sure.
You have the right, so the floor is yours. Good luck.
Okay. All right. So, my name is Pablo Fesenko. I'm not a teacher as previous speakers, but planning to become a math and physics teacher in the future. I like new technologies, and I also like sharing them with others. So today I'm going to talk about integrated STEM, Raspberry Pi. Let's start with integrated STEM. Many of you have heard about the abbreviation STEM, which stands for Science, Technology, Engineering, and Mathematics. When people talk about STEM, they talk about teaching usually one of these subjects, so for example, science or mathematics. But important is that STEM can be integrated, which means that the different subjects can be taught at the same time. For example, mathematics can be taught based on scientific examples using technology and engineering. So the advantages of this approach is that it's cross-disciplinary because it combines different subjects. It gives a better understanding of, for example, mathematics for students that can apply it to science or other fields. Because cross-disciplinary, it's easy to make project-based learning using STEM. And since it uses extensively the technology, which is computers or programming, students can develop nicely computational thinking. But what are the challenges of integrated STEM? So this one is that there is actually no real STEM curriculum. So we have in the schools mathematics, physics, chemistry, but we don't have STEM. The reason is that it's very difficult to make one unique curriculum. And the problem is that there is no alignment to current assessment standards. This is another problem for teachers who actually have to prepare their students to actually pass exams. There are limited teaching tools that can be used for teaching integrated STEM. So today I'm actually going to show you one of these tools, and I hope you like it as well as I do. Raspberry Pi. So Raspberry Pi is a fully functional mini computer which costs only $35, and this is an image of it you can see here. The size of the credit card, so it's small. Since the time it was launched, already 10 million Raspberry Pis were sold. Even traveled to the International Space Station as a part of the AstroPi challenge for schools. So the advantage of the Raspberry Pi over other computers is that you can see the multiple pins coming out of it can be used to interact with other objects. And those objects First of all, you can make a robot using Raspberry Pi. You can attach sensors to it, you can attach a camera, and you can also see the prices for all these parts are extremely affordable. What's better that all these parts can be integrated with each other. As you can see, the eyes of the robot are actually an ultrasonic sensor which can sense the distance to the objects and can be used for avoiding collision. Map all these teaching tools on, for example, the units of physics, and then teach mathematics based on this physics concepts. Let me give one example. So on right you see an example of the Mars rover built with a Raspberry Pi. And here on the left, you can see the different parts of STEM that are used here. So first of all, from the part of science, you have to relate speed, distance, and time. For technology, they actually have to program how to move the robot, so they have to use coding. Part of engineering, they actually have to build the rover. They have to think what sensors would be nice to put on it. Part of mathematics, they will use some linear equations to describe motion. So what is my proposal today? I would like to create an integrated STEM curriculum for your classroom. I think this is definitely possible, and we should take action. So if you're interested in these ideas, or you just would like to know more information, please contact me on my email, pavel.fesenko@gmail.com. Yeah, I hope you liked the presentation, and in the end, you also can see the references which you can later use to check all the tools that I presented today. Thank you very much.
Thank you very much, Pablo. It has been really interesting, and good luck for your future as a teacher. I'm sure it will be a great one, given the presentation.
Thank you.
Okay, thanks. So let's move now to the last speaker this evening. You all know her, I'm sure. Her name is Irina Vasilescu. She's coming from Romania, and in the meantime, I am giving her the presenter's rights, so she can speak. She's gonna share with you her learning designer. So she will be sharing her screen. In the meantime, if you have any questions for any of the participants, please post them on the chat, and after the presentation of Irina, we will come back to them. Okay, Irina, are you ready?
Yeah, I'm
time, so we need 1 more minute or 2 is fine, okay?
Okay, great. Can you hear me?
So yes, we can hear you.
Okay, so I'm very glad to be here with you. I've been very honored to be one of the moderators of this course, and I want to thank you for all the work and for the company and for all the efforts that you've done during all this course. I'm a math teacher. I work in a lower secondary school. This is my 30th teaching year already. And besides teaching math, I've been working in a few European projects, some comenius projects, and also some projects that were implemented by European schoolnets, such as Scientix and Genius, and of course eTwinning, for several years now. And I'm going to show you design an activity called How Could We Escape the Bermuda Triangle? It's a PBL type activity, and it's focused on 7th grade geometry. Some grade students are 13 to 14, and the topic is triangles, of course, classification, perimeter, area, and important lines in triangles. But a starting point is this one. It starts from a little story, from a little challenge. National Geographic is looking for young investigation reporters, and so students will work in groups trying to get this job, to be appointed for this job, and their task, the assignment in order to get this position is to explore the Bermuda Triangle from several points of view, including the mathematical one. And only the best team will be employed by the famous magazine. They will use Google Maps for this, and GeoGebra, and whatever ICT tools they want to. And what they have to do is to measure the sides and angles of the Bermuda Triangle, calculate the perimeter, find what type of triangle it is, and then find at least 2 different ways for calculating this area. And this they will have to explore and discover some new ways to calculate the area of a triangle, as Heron's formula, Pick's rule, maybe split the triangle into smaller ones, enclose the triangle into a rectangle, maybe use GeoGebra and do some scaling. We'll have to work on a presentation and present their work to the peers, either using ICT tools or just using a model or a poster. This module is an introductory one. Is focused on group forming and ice-breaking activities. After they are explained the task, they will have to create the groups, and in each group there will be 4 roles. The 4 members of the group will be a researcher, another group member will be a mathematician, the other one will be the ICT expert, and of course each group has to have a coordinator. They want to decide on the roles, and the teacher can use a tool called Teamup in order to monitor the work of all the groups. This is the shortest part of the activity. I forgot to tell you that the whole activity is 3 hours long, but 1 hour can be assigned as homework. So this, the second and main part of the activities is the one where students investigate, discuss, learn, and apply the new information. They will have to search some web sources indicated by the teacher and decide on the best strategies to use in order to find the information that they have to present, and then present a clear and consistent presentation. They are going to with their roles. For example, one is going to search for historical and geographical data about the Bermuda Triangle on websites that the teacher has indicated, because every time they have to study the internet, they have to be taught how to do it, and indicated some web pages that are more reliable and less risky than others. The ICT coordinator has to check on the reliability of the sources, and this is a good a good moment to teach about online safety, online reliability. Before starting the mathematical part, they have to see the rubric that they are going to use to assess their work. And the rubric they are going to use create with RubyStar, with a tool that is very good for creating rubrics template. You can see it here. I'm going to share all links afterwards. So after this, they are going to I have to go underneath this. Okay. After seeing the rubric and maybe changing the rubric if they need, they're going to search for, they're going to brainstorm for ways for calculating the area of the triangle. Also given some sources, and they're going to research and understand Pick's method and Heron's formula. They're going to try to use GeoGebra and scaling, and so they have to decide on the best ways to calculate the area. Then they have to find the area in 2 ways and compare the results. And of course, the mathematician of the group should check work and the results for accuracy. Then to collaborate on creating a presentation for the results. And this can be also a presentation, a city presentation, or they can decide on presenting by a poster, by using a poster, or maybe a model or something like this. Then in the third module and the last module of the activity, they have the opportunity to assess and reflect on their work before presenting it. I asked them to work in 2 groups and assess each other's using a tool called the ladder of feedback, which I'm also going to share with you in the chat in a moment. Then after doing the adjustments according to the other groups, to the peer groups suggestions, they can present their work to the whole group. Because I actually did this. This is a short video. I don't know if you can see it. I hope you can. Of how it worked and how it worked to their peers. So the altitudes and the midlines, they calculated. In the end, finished activity by teacher's work. I think that was all. Thank you very much. I'm going to share all the links in a moment in that. Thank you for being patient with me. Can I have a question? Can I have a question? There's a question about team up. Can I answer it? Team is a tool with which you can form groups, and then you can measure the work and the progress of each group. Any more questions? is asking if we can share each other's. The webinar is finished. Thank you very much. This is all for tonight. And the webinar, everything will be shared in the web course. We will see everything again and share the and the links and everything in the course. Thank you for taking part. I'm encouraging you to share as many learning designs as you wish on Facebook, so we can all see what the others have been working. It's very inspiring to see each other. See everything that was shared tonight in the course, web page of the course. Hello everyone. Thank you very much for sharing your work and sharing time with us.